Um, so today we are going to discuss about circuit theory, right? So this is the course on basic of circuit theory, um, based on Raghavi's lectures. Uh, we'll find similarities with them. So let's start. Um, so why circuit? The most basic question comes is that why circuit theory? Why do you want to uh, learn circuit theory at the most basic level? So why do you make circuits? So there are various electronic gadgets around you. So as there are various electronic gadgets around you, how we make those electronic gadgets? The you have heard some component names like resistor, capacitors, inductors. Someone might have heard about diodes, etc. So we have to make meaningful connections. We have to make meaningful connections of those electrical or electronic instruments, rather components, and by that thing we make a circuit. Remember one thing, we have to make meaningful connections, not like that we are like connecting it somehow or the other. Not like that. We have to make serious and meaningful connection. That's where circuit theory plays a role. We will see how we can make circuits, and and how we can make legitimate circuits that will work accordingly. What job is there for the circuit? Like, uh, like for example, a radio station is there. So radio station transmits the signal from the radio station. Okay, and what happens when you want to hear about the radio? In the 90s, televisions were very less. People used to listen to radios. Of course, now also this TV, you will find one low noise amplifier in the this TV. There is a mic type of object in front of the dish you will see. So there is a low, it is connected to a low noise amplifier. So, um, so there comes the electronic circuits. Electronic circuit comes into play on that part. Okay, so that is the thing. Uh, so circuit theory helps us to make useful electronic items, to make circuits which will be used to make useful electronic items that we can use in our daily life or in various military component uses, space research uses, or any type of use. So, what do you think? Every type of circuit has been invented? Not every year. New type of circuits are being generated. Uh, Researchers work on making different circuits, new circuits every year, everywhere in the world, in every country. Researchers are uh, publishing their work. You will, if you want to see, like in IEEE journals and conference papers, there are different types of circuits. Yes. For example, I will give a little one more example. What I am speaking is being recorded by the mobile phone's mic. So my word is a physical signal that is being transmitted to you. First, my voice converted from physical signal to an electrical signal by the receiver of the microphone. Okay, so that is a transducer. That is a transducer. Transducer converts something into electric, some form of signal, whether it is electrical or physical signals into electrical signals. And vice versa, you can do. So that microphone transducer is converting my physical sound signal into an electrical signal. It is being then amplified because after converting to electrical signal, so my sound will travel this far via radio frequency. First electrical signal to the video or something to the to my laptop sending first. Then when I will upload this video, then from the audio and the video will be gone to some platform, and then that platform will come to you and show it in your phone or desktop wherever. So in this long process of internet and sending, receiving, like see here, uh, I am speaking, I am speaking, and then is being transmitted in the, like, here is a mic. Okay, so this is a mic or transducer. Yes, it converts this signal, it's a, this sound signal into an electrical signal, like this electrical signal. Then this transmitting is transmitting receiver signal. Then again your phone receives this signal, and then it converts again into a voice signal. Okay, so so circuit theory and electronics comes in this part, in, in converting the sound signal over here. Then again the electrical signal is transmitted via antenna, and then it is received by one antenna. Then antenna is converting this into electrical signal inside the receiver. Then receiver is also giving output to the speakers, and the speakers are generating voice signals. So here and in between this is a long range, suppose 10 kilometers. 10 kilometers are there. So here we need to amplify the signal. Amplification of signal takes place. So to amplify the signal also we need electrical circuits. We need electrical circuits. So the question of why circuits, very partial. Okay. So to make circuits, you need to first understand the electrical quantity. We start by electric quantity. Start from electric quantities. Okay. So first of all, charge. The most basic is charge. Its unit is coulomb. Done in physics. So, what is charge? We really don't know. How to explain charge? We really don't know. Yes, they have made a point for some particles, protons, subatomic particles, like protons are positive charge, electrons are negative charge, neutrons are neutral particles, like that. Charge is a physical property that given a term to it, to the physical property, like positive and negative attract each other, positive repel each other. This physical property we have given a name. We just get an idea that proton have a positive charge, the same equivalent charge is there inside inside a electron, and that is of negative quantity. Just given, take it as an anatomy, not nothing more than that. Then now comes, why do we need to flow current? What is current then? Current occurs when electric charge flows or moves. So, how does current occur? Current occurs when electric charge flows or moves. The definition. So, let's suppose here is a water pipe. Water is flowing from here, getting out from here. So what do we say? A water current in a river, like river current. We have studied in geography in maybe a 6, 7 or 8. Studying a river current is flowing down the hill. So like that. Suppose in that pipe, water current moves from one place, this place to this place. Okay. So what happens is that one molecule of H2O goes here, then one molecule takes its place, then this molecule goes here, and then some other molecule takes its place. Like that, water current moves. Okay. So this is how in a wire charges flow, and that is known as electric. So in a pipe, water current flows. Inside a wire, electric current. And charges flow inside a wire. Then we say current flow. And so when charges flow in a specific amount of time. So let us say I is the definition Q by the time taken to reach from here to here. So is this correct? No. Why? We have given a question mark over this. Let's suppose you have one cell. Let's suppose in a circuit from this point A to point B, Q charge is flowing. Okay, Q charge is flowing in one second. In 1 second. Suppose my voice signal is of 3.5 kilohertz. Okay. My voice signal is of 3.5 kilohertz. So, we can hear from 20 to 20 kilohertz. Human ear can hear. My voice, suppose it is 3.5 kilohertz. So, what will be the kilohertz is the frequency? So, what will be the time period of it? 1 by 8. So, if you write kilohertz here, that's 1000. That is 1 millisecond. You're getting 1 millisecond. So 3.5 milliseconds is the time period of this thing. Basic time period is 3.5 milliseconds. So I told that my voice is being converted to first electric signal to the transducer, and then that electric signal is being transmitted to the air or somewhere, and who is transmitting that for the antenna. Okay, so to first to transduce the sound signal into electric signal, then transmit the electric signal to the receiver. We are converting the signals first from sound to electric. So whatever you convert, but whatever you convert, the signal's frequency will remain same, or else you will make some other kind of signal. If the signal frequency not same, then you are distorting the signal. You are making different signal. You are not transmitting the exact signal. What I have told, where like I told, my name, and you are transmitting name mine. This is different. So the minimum time period is 3.5 milliseconds. So the transducer have to work in 3.5 milliseconds. Whatever electrical or electronics component we will use will have to work in like in 3.5 millisecond of a second, 1000 part of a second. You have the transducer have to work, or the antenna have to send the signal. So suppose this is a wire inside the antenna. So if some current is going inside the antenna, it's a signal, then how can the antenna send the signal if it is not working in 3.5 milliseconds of time period? It is working. We have told here that in 1 second, how much charge will flow from A to B. So inside our antenna, if my signal is of 3.5 kilohertz, means the time period is 3.5 milliseconds, and we are calculating the current inside the antenna in the basis of 1 second, then in 1 second, no current is flowing. In every 3.5 milliseconds, we have to just like you are moving, our human eye can see in 24 frames per second. So if someone moves very fast, will not capture. Like if you capture one photo and some car goes at 60 kilometers per hour and you cannot click the image. So the car will go, you will get a hazy photo of the car. Why? Or hazy video. Why it happens? Because your frame rate is low. Frame rate is high. frame rate is low. Frame rate is low, that you are capturing in like 10 frames per second. So in 1 second, the camera is taking 10 photos and making a video, and one camera is taking 24 photos and 60 photos. So the time will be accurate. It will not be a time lapse. The 10 seconds you are taking one photo. That is time lapse. Slow motion. You are taking many photos in single time, single unit of time. Okay. So that is why this cannot be defined. That many circuits cannot exist till 1 second. Then what will? Then how will define current to that circuit? There comes, we have to minimize the time so small that every circuit, wherever current is flowing, we can analyze the circuit, analyze the current. So, what do you know? How T, how do we make T very small? We make T very small. So we know that we write dt. So that's why I is dq by dt. This is the main definition of current. So how much charge is flowing from point A to point B? Okay, from point A to point B, and in how much time? And also write it like this: del q by del. Okay. Important points are right down. Each current has a yes. So one important points that each current has a value I and always a direction. This is very, when you have a circle and you always mention the direction of current, direction of current. Okay. And current will always have the value and the direction. Now, an open circuit defines current is equal to zero. What is the important point? First one is direction. Current will always have a value and a direction. Second point is open circuit always tells that current is zero. Open circuit does not guarantee about voltage. It will be guaranteed by different elements connected to this circuit. Okay, will be made to that. So here comes one question that how so we know that someone might say the later part of the course that the open circuit voltage is infinite, but you can find that some resistor is here and you're opening the open circuit over here, but some resistor is also connected here and also connected here to this. Okay, so current does not go through there, but it can go through here also. So the VA and VB, we can find the VA minus VB is finite. Can find the difference of point, the difference of voltage in these 2 points. Whether this is open circuit, current will not flow from here. It can go from here and here. So the main point I am trying to say is that, that the open circuit, that one open circuit guarantees that current will be zero. So that open circuit, but it does not guarantee voltage. Now, one important point is about charge. So, if some question is there, then current is there, and why there is current, and why there is uh, no charge. So, charge is able to, you have to find the charge. How will you do it? Just integrate the current respect to that. And I equals to dq by dt. So q, you integrate I into dt. Okay, from 0 to time t1. Okay, 0 to time. So let's do one example. I1, this is t1. So what is the charge flowing? What is the charge flowing this to this? Uh, so from current, let's suppose first draw one side. This is current versus time. So first I could draw one circuit that can have this ground. Right. Now I will show you. Let's suppose there is a voltage. There is a switch. Then you can connect the register over here. So this switch closes at time t1 and opens at time t2. This is the sign. This is the sign of closing at time t1. With closes at time t1, current flows to the register. Current makes it up, and the switch again opens at t2. So now, what is the charge? Total charge flowing. Remember what I told? Charge is the integration of the integration means area under the curve. I1 times T2 minus T1. This is the charge to the register during the time to integrate by 2 equals I T2. Okay. Now, the next quantity is next electrical quantity voltage. The next electrical quantity is voltage. So you have studied maybe in physics that what is voltage. Okay, so I studied that. So let's try to define what is voltage. Suppose there is a point A, one circuitry there, and 1.2 circle. See the whole circle. Now let us assume some charge is there, which is one positive and unit charge. It's very important. You should remember positive and unit. Positive and unit. So taking a 1 coulomb of charge and the hear it carefully, it is important. What is the voltage? The energy required to move 1 coulomb of charge from point B to point A is known as the voltage. The amount of energy required, the amount of energy required to take a positive unit charge from B to A. It's the positive unit charge and the amount of energy, the amount of energy that I require to push this charge, push out this charge from this point B to the point A is known as unit voltage. So let's get one physical example. Suppose here is a metal plate and here is also. Don't think this is a capacitor. Just I am giving you. Suppose I connect a battery minus. So what this battery will do, it will accumulate positive charge over here and negative charge over here. Okay. Now let us assume that I have kept 1 coulomb of charge, but what is the charge? What can be the charge? What are the requirements of the charge? It should be positive and it should be unit. So we are taking 1 coulomb of charge and we are trying to get this up to this plate. Okay. We are trying to move this 1 coulomb of charge from this metal plate to this positive. This is the voltage. This is the V. Similar to this. So this V is giving the difference of positive charges over here and negative charges. If you keep one charge, positive 1 coulomb charge over here and move it back to the positive plate over here, then the energy which will require would be 1 voltage. What the value of voltage? Okay. You understand? Now some important points. In the current, I have said the current must have a value and a direction. In case of voltage, voltage must have a value. Okay. And it must have signs, positive and negative. Must have signs. Like resistor is there. If we can measure it like this is the plus voltage. And if we measure it like this, so the point over here has a V voltage more. See, the point over here has V voltage more. Over here, the point over here has a V voltage more. And here has, you can say minus V voltage more or V volt less. So what? Okay. So the signs are very much different from the coefficient. And one point to another voltage is meaningful only between 2 points. But meaningful like here, what is the voltage? 0. Between 2 points, you can calculate. Now, in open circuit, I have shown you that no current will flow. I will be what? 0. What does short circuit defines? What does short circuit? Short circuit defines that voltage is 0. In between these wires, no voltage is present. The charge can move freely from here to here. Okay. So short circuit defines voltage 0. Open circuit defines the current 0. Okay. And the short circuit does not say about current. Current might be in milliamperes in a short circuit or might be in thousands of amperes in a short circuit. It again gets defined from the like from the other elements connected to the source, connected to the circuit. Now I will choose one minus or sorry. Draw the V out of this circuit. What will we do that to draw the circuit? Right? Hmm. So see, this is the input voltage. Input battery is there, VB. This one is one resistance. This one is it. We are calculating the output V out across this R1 resistance, right? Across this R1 resistance. There is one switch. There is one switch at t equals to 0. The switch gets closed or it is open from minus infinity. So if it is open, will there be any voltage? See, no current is flowing, so current will not drop from Ohm's law. But we have learned that V is equals to IR, right? So when current flows through resistor, across the resistor, we'll have a voltage V. Okay? This is the multiplication of current and the value of the resistance. Okay. So now what will you see is that, so if there is no current, current is zero, the voltage is also zero. The current is zero, voltage is also zero, like that. So when switch is not closed from before t equals 0, the current is 0. Right. When t equals to 0, the switch closes. Switch becomes like this. So the current rushes to this also. So as we said, the voltage of this point and this point is same because it is a wire. No resistance is there and no drop is there. Calculate the distance, the voltage is zero from here to here. So the VB is over here. So V out will be increased to VB and it will be constant like this. Now some more wire told you in an ideal wire, the resistance, inductance and capacitance all will be zero. It will act as a short circuit. Then switch the switch, then voltage. Now comes voltage. The sign of voltage source is this. No, this is the sign of a constant voltage. Sign of voltage source is this. This is a no. This is the sign of a constant voltage source. Okay. This is a sign of a constant voltage source. This is the generalized voltage. This is a sign of it can be cancelled. But is a voltage two-terminal device voltage does not depend on the current flow. It is a two-terminal device whose voltage does not depend, on the current flow. Like whatever current comes inside or goes out from the voltage source doesn't matter. The voltage source will always try to maintain the voltage across it, like here. The voltage source will always try to maintain the voltage across it. The same voltage across it. Whatever current decreases, current increases, see the current will in R2 when R2 only resistance was there, it was an open circuit, so only the current was flowing from here to here. Okay. The current was more, right? When one series R1 was introduced, resistance dropped down, the current becomes more. When there was a single resistance, let the current was I1. When both resistance comes in parallel, the resistance decreases and I1 increases. What if I1 increases? If I1 increases, whether the voltage will change across this point. No, this is a constant voltage source. Voltage source always will try to maintain the voltage across these points, across its its, its two terminals. So the voltage will be similar, VB only. We are talking about ideal voltage. Okay. So understand it more. Let's see. Let's draw one. Okay. Suppose this is a constant voltage. I current is flowing the R register. So from Ohm's law, what we have got, I is equals to V1 by R. So let's draw the graph of dependent I and independent V1. The graph will be a rectangle height. Height, not rectangular. Not, it will not be just this one. Whenever the voltage will go down, current will rise to R1. Whenever R1 and R1 is varying, whenever R1 goes high, current goes down. And whenever R1 is less, current goes to low. In ideal cases, the current will not go to infinity, it will go here and stop. Why? Then the voltage source will decrease its voltage. Like a battery will what we have to recharge the battery, right? Why? The voltage of the battery or the current goes down, potential goes down the battery, then we have to recharge it to its full level again. Why it happens? In practical cases, the voltage source will decrease its voltage, so the current will not go to infinity. Now, independent and dependent. This we have talked about independent. So, in dependent sources, we write it like this: plus minus. There doesn't exist any cannot buy any dependence or going to any electronics. No. Does that uh, there are various models will learn like in analog electronics will learn so like op amps and transistors. So those will be like those will be when we have complex circuits made up with those elements, those reflect about a voltage source or a current. Okay. After that, some questions need not do that. Then current source. What is the current source? Current source is like this. Dependent current source is like this. Suppose it is dependent on the 2 this one. Whatever the value of V, even increases or decreases, current source will decrease accordingly. So this one is dependent on this one. K is the scaling factor. Yeah, this is scaling the word. Scaling. One thing cannot connect to voltage sources like this. Because if it is 3 volt, suppose it is 2 volt, this current will be got infinite. It will go very high and it will damage the 2 volt source and later 3 volt also. Why? Because there is no resistance. R is equal to 0 of an ideal wire. So we can connect a current source. That is how charge our batteries. Model the currents. Okay. And after that we will